Okay, so one of the questions here is how is a single user application different from multi-user application? And that's a generic question you need to answer. So I'm just taking a very specific application. Okay, it's an echo application. So it says, please enter an excerpt from Frost Stopping on a Woods on a Snowy Evening. Do you remember the poem? No, the woods are lovely, dark and deep. Okay, yeah, you learn the poem here. So you can say, let's say Alice. This is Alice, single user. Okay, she says something, and there's some work going on in the background because I'm going to make this collaborative later. So you get back and feedback. You get feedback saying you said the woods. Okay, and you can say are lovely, and you get feedback. Okay, you get some feedback. So this is a single user application. Okay, and it's somewhat like the IAM application that you have to build, where there's only one user working, and then you have to make it collaborative, right? So the question is, firstly, even though it's single user, it could be it could be a distributed application for single user, or it could be a non-distributed application. Okay, so basically, almost every collaborative application is a distributed application, but every distributed application need not be a collaborative application. So can you imagine? I could have done this all in one process. I'm not doing it in all in one process. So can you imagine how this could be in some way distributed? So how could I mean, this what this application is doing is basically capitalizing my letters. Okay, and what all this is it says you said are lovely, and then it says Alice, you have said two things. Okay, because you said two things and others have said nothing. Okay, so the question is now, when you have distributed application, you sort of have a client server application, right? So what might you put in the server here? Or what's it doing? It's just capitalizing. So you could imagine putting the capitalization in the server, and the client just goes and sends it to the server. That's it to the server. Okay. Then you can imagine the server actually going and counting how many messages Alice has written. Or you can imagine the client doing it, and the server just makes a callback distributively. Okay. So just because we want things to be complicated from a distributed point of view, because I'm trying to show you some algorithm here. In fact, the capitalization is done in the server, and the server calls back the client saying how many messages have you sent. Okay, so this is actually a distributed application, and you actually see a server here. Okay, this is the server. You don't see. I mean, I'll show you the user interface. I mean, I'll show you what it does later. But there's actually a server window here. There's actually some activity going on in the server that made this all happen. Okay. So the next question is, what if we make this? What happens when a new user comes in? Okay, so supposing I now say start Bob. Okay, so what should Bob see when Bob comes up?
That your Alice already sent two
messages, right? Okay, so that's one semantics. If you look at user interface design, they also say, hey, maybe there was a collaboration going on and they were talking bad things about Bob, so maybe Bob shouldn't see. Okay, from a technical point of view, it's just, and that's exactly what should happen if it's all working right. Okay, said the woods are lovely, the woods. Okay, and Alice said are lovely. Okay, so you can see now that in this application, uh, what Alice sees and what Bob sees are different things. Okay, Alice sees you said are lovely, and Bob says Alice said are lovely. Okay, now that seems like a small thing from a design point of view, but from what's going to happen next, actually, it just complicates the algorithm like crazy. What the algorithm I'm going to show you later. The fact that you might have to say different things to different people. Okay, many times when I was developing this algorithm, I almost thought of giving up and saying let's just make it all the same. Okay, so now the question is, I actually have two servers. Okay, I have, and they're both doing the same thing. So if I have two users and two servers, what could the second server be doing?
The two servers need to know. Well, one server should communicate to another server.
Okay. So there's sort of the implementation issue, right? But why do I have more than one server? Why not just have one server than one server?
The server is not overloaded with too many requests.
Okay, so that you can distribute the activities, right? You can say, I'll do half the work, you do half the work. Okay, and also imagine that you're in India, and you and there's a server there, and there's another server in America. You'd rather go to your local server, right? The latency will be also small. Okay, so there are many reasons for doing this. Um, so let's just see what's happening. Okay, let's try to see. So through this user interface, and this is something you guys might use at some point, I can actually set like a breakpoint. Okay, so I'm not using a debugger because debugger uh, actually. Uh, so let's go into a single step. Debugger involves a different user. I can't you have to keep swapping between different windows. So let me go and say you said are lovely, woods are lovely, and then the next part of the poem is dark. So let's just say Bob says dark end. Okay. So at this point, both these proceed buttons come up. Okay, which means that the program is halted. You didn't see any output. So let's go and proceed this guy. Okay, you see still no output. Okay, let's go and proceed. Do a proceed here. You see the output now. Okay, and so maybe this server is serving Bob and this server is serving Alice. Maybe that's the case. So let's test that theory out also. So let Alice say and deep. Okay, so let's go and again proceed this guy. Again no output. Proceed this output. Okay. So as it turns out, your theory about distributing the load, or my theory about having small latency is not working. So if that's the case, why might we have another server? We're not distributing the load. They're all going to one server to get the real output. Security, well, I mean, more servers you have, more programs you're running, more things can go bad, more attacks actually.
Okay.
So you often have multiple things. If you don't trust somebody, what might you do? You might give one student the task, you might give another student the same task also, just in case the first student fails, right?
Yeah.
So you might have, what's the technical term in computer science? Fault tolerance.
Yeah.
Okay. So let's see whether we can get fault tolerance. Okay. So you said deep. The woods are lovely, dark and deep. I have promises. So let's just say I have. Okay, and what we're going to do is we're going to let the server 2. You can see that they're both keeping in sync.
Yeah.
Okay, and this is what your theory was, right? That they're talking to each other somehow. That's why they're keeping in sync. So what I'll do is I'll make this guy go ahead. Okay, and then what I'll do is kill this guy. Okay, so at this point, what should happen? Bob has said, I have. Nobody's got feedback. If all goes well and magic happens, this server, which has already gone ahead, should go and give the same output. Okay, and sort of the analogy I used in class, which was, there's the Hydra mythology there's the Hydra monster. There was a Hydra monster. I don't know, Greek mythology. I don't know which mythology. And it had multiple heads. You would, as it came to attack, with one head, if you chopped it off, the other head would take, right? And you don't want the head to start off at the beginning. If the head is about to strike you and the new head comes up, it should be right where the first guy was, right? Or Ravan with multiple heads. Okay, so I gave my brother a demo of this, and they really hooked onto the Ravan analogy. So let me kill exit.
So that proceeded.
Okay, so that's good, and this is sort of kind of complicated stuff. So then, of course, the question is, how did they know, one should take over from the other? And there are all kinds of complicated algorithms do such things. As it turns out, the clients are keeping track of, who's alive, who's not alive. And when the client realizes that some server has gone down, it goes and contacts some alternate server. Okay, and the alternate server says, "Oh, you haven't heard enough messages from me, so let me go and replay those messages." Okay, so it's a complicated algorithm. It took me a long time to get it working, actually. Okay, so let's go and see whether things are happening. I have promises. Okay, let's again make this proceed. Promises, okay. And Bob says to keep. And now what bad things can I do?
Kill this.
I kill this guy. So it's like, all of Hydra's heads are gone. All of Ravan's heads are gone, and now you need. So how would so what would happen then? I mean, I'm stuck. I want to know. There's this to keep message. So should we just give up on that and start a new server, or could we, So what should we do then? We kill this, then we have to start a new server, right? And hopefully that server will take over from where the previous server gave up. Okay. So we'll kill this. Okay. It's got nothing happened.
Yeah.
It just got the error that lost connection to all servers. And I'll start server 1 again. There should be another window that's coming up. Okay, here's the other window. Okay. And and see to keep.
Yeah.
Okay, so that's magic, right? Again, it took me a long time to get this working also. Okay, so and we can just see that this server is promises to keep and miles to go. Miles. Well, I guess I didn't single step that. So we got n miles here. So this is working. Okay, so where did the server get its data from, you think? The server, initially all servers were hearing everything. So it was easy for the second, it's like Hydra monster. It's one head, all the heads are listening, but only one head is active.
Yeah.
And so the other heads can take over. But this guy was not even alive. So where do you think it got his information from? Isn't there many possible answers?
Yeah. It could see what users. It could get the data that is stored in a user.
Okay, so somehow the users gave them the data.
Yeah.
That could be that the users got to know, and they say this is what we all did, and it has to be all in the right order.
Yeah.
It could have been written on a disk.
Yeah.
As it turns out, all of the communication is going through another server.
Okay.
Okay, which is the static server that I've got here. It's a latecomer server. It's the same server when when Bob came in. Bob had to figure out, right? We had to go and show Bob all the Alice's messages. So at that point also there was quote unquote some recovery action. As it turned out, Bob saw different messages from what Alice saw. But Bob had to get the gist of the communication. So that problem at the abstract level is similar to this server problem, where the servers come now late to the collaboration. In this case, the server sees identical, exactly same things. Whereas in that case, they could see different things. So this framework is such that it can accommodate both things. Okay? So, and just to show you that, here's that server. And I'm going to single step this guy. Okay? And miles to go. Okay, and now what's happening is I'm not going and putting breakpoints on this server. I'm putting breakpoints on this relayer, through which all the messages are going. So if I go and say proceed once, it sends the message to the server saying, I want capitalization. I say proceed once. The server goes and sends back to Bob saying, how many messages have you sent? Okay. Then proceed one, the return value goes back to the server. Proceed again, the message goes to Alice, and so forth, till we see to go at both places. Okay? So now what bad things can I do? Okay, we'll just make Bob do the same thing. Okay? And I'm going to kill it not at the beginning, but one message, two message, three message, and I'm going to say exit. I don't know if it's going to work right now or not. Huh? Not bad, huh? You got and
Okay.
So you got the output.
Mm-hmm.
So what do you think is happening? So I killed this server.
You killed the static server,
and in the middle of it sending messages,
Yeah.
and somehow by magic,
So server one, use something.
server one knew something, but then the message was being relayed here. We still need the relaying. Yeah, so somewhere
Yeah.
there's information.
Yeah. Yeah.
Okay, so when we kill server one, server two took over, right?
Yeah.
So couldn't we have the same thing when the static server dies?
Yeah. Server one.
There's another static server maybe which I'm not showing you.
Oh, now there's.
Okay,
Uh-huh.
so there is actually another static server.
Okay.
Okay, and so it's the same again. It's the same kind of idea being repeated, and I think this is the static server.
Okay.
No, this is the. Let's see. Yeah, this is the latecomer server too. Okay, because you'll probably see some messages. Miles to go before I sleep. So let's go and put I sleep. See, you saw some activity and you got the output.
Yeah.
So what if I now want to kill this server? That's the last server I have left. Huh?
Okay.
You might want to start another latecomer server. Yeah. But then who's the latecomer server? Where will it get its, this was a server, right?
Yeah.
So you have to stop the recursion at some point. Okay. So that was the basic demo I showed, I gave there. And the idea is that, got some algorithms here, obviously. And I believe this algorithm is actually a new one. Huh? It's not because of all the constraints I put in. I mean, this idea of replicating is very old, but replicating at the front end is new, but it's also the architecture. Okay, so there are many architectures possible. So that's the other thing you learn in this course. And the main thing is that the abstraction. Okay. That I didn't build an application for IM here. What I've done is build a general framework in which you can build any distributed application, and it is such that so this abstraction, there's reusability. Plus, like I said, there's replication there going on at the client level, at the basic server level, who's capitalizing it, and at the latecomer server. And there are differences and there are similarities, and the framework is designed in such a way that whatever the implementation differences are proportional to the conceptual differences. Typically, what happens is that you've got, and when it comes to implementation, they're totally different. In fact, even PowerPoint and Word, even though they look the same, they behave the same, absolutely different code bases. So this course is going to be a lot about these three things. And abstraction is going to be pretty much the most sort of complicated.